Greetings. In this example video on mechanics, I want to talk about the velocity of an object after some height of falling. So let's say I have an object and it is falling a certain height. Alright, so it started at velocity equals 0 and then it was falling down here up until here. Let's say it's a ball or anything actually. I'm considering it in a vacuum, and by the way, the acceleration, the gravitational acceleration that makes it fall down, I will say that it's g, and I will say it's approximately 10 newtons per kilogram. Or even more used in this particular example, it's 10 meters per second squared, which is the acceleration I'm talking about here. So I'm actually not even considering the mass of this, but I will use a nice equation in mechanics in order to derive the final velocity after some height of falling. So let's say the height it has traveled so far is h. And so how am I able to do it? Well, there's more ways. For example, one of the equations that can be used in order for me to derive an expression that explicitly tells me after some height what the velocity will be. And by the way, I'm considering zero resistance. I'm considering there's no air, and this is taking place in vacuum. Otherwise, with air, of course, in smaller heights, it might not affect yet that much the result. But in bigger heights, of course, there will be terminal velocity, after which the ball actually will reach a constant speed, and the friction of the air will be same like the accelerated tendency. So the ball will be falling at constant speed for some time, which is also an interesting phenomenon, but to be developed in another video. So anyway, an equation I can use for this is this nice equation: 2as equals v0 squared plus v squared. And what this tells me is basically that if I'm starting at 0 at some velocity and I square it, I add to it the final velocity and square it, it will equal 2 times the constant acceleration, taking into account that the acceleration is actually constant, which thanks to this g equals 10 meters per second squared on Earth that I'm taking into account. Of course, slightly it changes along the way, but in general it can be taken with simplification as constant. Let's say that 2 times the acceleration taken into account, the constant one, times the distance traveled, which is the height here, that's equivalent to it. That's what the equation relates. So basically, the equation talks about the relationship between constant acceleration, in this case, the height that the ball is falling, and then its initial and final velocity. So I can just plug in things here. Well, s will be the h here, right? S is my travel distance. So s will be the h here. So 2 times h. I just replace the position of these two. And the a, that's the acceleration, and my acceleration here is the g. So I can either say g, or I can already say the 10 meters per second squared. I can just put it here, right? This equals v0 squared. v0 is my initial velocity, and I said that I'm looking for a formula which talks about a ball or any object that was dropped, but it started falling at velocity equals 0. So the zero velocity will be 0, and then the final velocity is what I'm looking for. So now I can just manipulate this equation further and finally get an explicit expression for the velocity, which is the final one. This v is the final velocity. So v, and then square root this, well, square root, and actually instead of the 10 meters per second squared, I might just use h. I might just use g. So I can square root both sides. V equals to square root of 2 j times g. So this is an explicit expression for me to use in order to evaluate that after some height what the velocity of the ball is, taking then the constant acceleration due to gravity is 10 meters per second squared. That's just a model, just an approximation, and taken a particle height. So for example, I can have height equals 5 and the g is 10. Therefore, the velocity after 5 meters should be the square root of 2 times 5 times 10. And that is the square root of 100. So after 5 meters, with this constant acceleration, the ball should be traveling at 10 meters per second. Alright? And by the way, this exact same expression can be derived from a different equation as well. The equation is as such that basically, one can say that the ball was starting here at v equals 0, let's say again, and then it was traveling this height, so exactly the same picture. It was going down to here, and then here the velocity is something, and here's the ball now. I'll put it to the side. Here's the ball, and here, what is the velocity? Well, it's going in this direction. I can say that at the beginning, all of its energy was gravitational potential energy. And gravitational potential energy, it is equal to mgh. It is the mass of the ball times the gravitational acceleration times the height it is in. It will be this height. And then all of it, because it started moving, so it from the velocity 0 with speed 0, started falling here, accelerating up until this point that I'm taking into account, that I'm looking at. It got a particular kinetic energy, and all of this potential gravitational energy that I'm looking at with this h, for this h, got converted into kinetic energy, which is 1/2 mv squared. I'm not taking into account any rotational energy that it gained or anything, just a block, let's say not even a ball, it can be anything, and all of its energy got converted to this. And so what I can do now, I can use these two equations and I can make them equal and cancel out the mass, then move the 2 to the left side, 2gh equals v squared, and again get the same result. So v again equals to gh. So again, this is an explicit expression for my velocity after a certain height that the ball was, or whatever object was falling, and considering a particularly chosen gravitational acceleration, which on Earth is around 9.8, or I use for simpler calculations around 10 meters per second squared. So let me give one more example just for the end. It's again the same idea. And again the same formula, I just gave through a different way. So let's say after falling for 3 meters straight down with no resistance of air, then the velocity should be 2 times 10, and with this chosen acceleration g equals 10, then the final velocity should be square root of 60. Alright? And this might be further rewritten as square root of 4 times square root of 15 and simplified as 2 times square root of 15 as follows. And it is meters per second of